In this video, I'll explain how to write electron configurations. Electron configurations are a way to map where electrons are in atoms. Electrons are found in atomic orbitals that have different shapes, and they're labeled S, P, D, and F. You can see in the diagram that the S is a sphere, the P kind of looks like a dumbbell, and the D and F have stranger shapes. This is in contrast to the Bohr model, which basically just shows the electrons orbiting the nucleus in rings. Those rings are more like energy levels. Every energy level has an s orbital, and the one closest to the nucleus we call the 1s orbital. It's basically a sphere close to the nucleus where there's a 90% chance of finding the electron. We can shade in the orbital, and the shaded region represents a place where there's a high chance of finding the electron. This second energy level also has an s orbital, and we call that the 2s orbital. It's basically just a larger sphere around the nucleus. There's also a 3s orbital, but before that we should talk about the p orbitals. The p orbitals start on the second energy level, and they have a dumbbell shape. There are actually 3 2p orbitals, and they're along the x, y, and z axes. As you can see, when we start to overlap them along one another, it gets a little messy. The 3s orbital is a larger sphere, and the 3p orbitals are just larger dumbbells. On the third energy level, we add d orbitals, and on the fourth energy level, we add f orbitals. You could imagine it would be very messy to draw pictures of where the electrons are in atoms. So, chemists rely on orbital filling diagrams and electron configurations. Here we have an orbital filling diagram and an electron configuration to match. In the orbital diagram, electrons are represented by arrows. Electrons are first placed in the 1s orbital, and then moving up in energy to the 2s, the 2p, the 3s, the 3p, the 4s, and finally the 3d orbital. In the electron configuration, the 2 electrons in the 1s orbital are represented by the 2 above the 1s. The 2s electrons are represented by the 2 above the 2s. All 6 of the 2p electrons are represented by the 6 above the 2p, and so on. So let's go ahead and write the electron configuration for lithium. Lithium has 3 electrons. The first 2 electrons would go in the 1s orbital, and the third electron would go in the 2s orbital. So the electron configuration for lithium would be 1s2, 2s1. So here's an orbital filling diagram for lithium, and lithium has 3 electrons. So the first 2 electrons go in the 1s orbital, and then the last electron goes in the 2s orbital. Nitrogen has 7 electrons. The first 2 electrons would go in 1s2, just like lithium. The next 2 would go in the 2s orbital, and the final 3 electrons would go in the 2p orbital. So the electron configuration would be 1s2, 2s2, 2p3. Here's the orbital filling diagram for nitrogen. The first 2 electrons go in the 1s orbital, the next 2 electrons go in the 2s orbital, and then the last 3 electrons go in the 2p orbital. Calcium has 20 electrons. Its first 2 electrons would go in the 1s orbital, the next 2 would go in the 2s orbital, the next 6 in the 2p, then we move on to the 3s, and then the 3p, and finally, the last 2 electrons go in the 4s orbital. Finally, here's the orbital filling diagram for calcium. The first 2 electrons go in the 1s, then the 2s, then the next 6 go in the 2p, the next 2 electrons go in the 3s, and then the 3p, and the last 2 electrons go in the 4s orbital. There you go. That's how to do electron configurations.